Okay, on this video, I'm going to talk about conditional probability, and I'm going to talk about your third connector word of given that. So as usual, I'm going to share my PowerPoint with you and kind of talk you through it. Okay. Now, there are three connector words that you're going to be responsible for, and we've already gone over two of them, or. So remember, the probability of A or B is the probability of A plus the probability of B minus the probability that A and B happen simultaneously, and that's on your formula sheet. And the probability of and, like the probability of A and B, means that A happens first and then B happens. And so that's the probability of A times the probability of B given that A's happen. So we've already gone over or and in there on your formula sheet. So now we're going to go over this connector phrase of given that. So the problem might look something like this. You select one card randomly from a deck of cards. So what's the probability that the card is a king given that the card is red? And that's different than just what's the probability that the card is a king. So do you understand? I'm guaranteeing you that the card is red. And that changes everything. Now it's based on this formula for and. Let me kind of show you how the formula is derived, and then we'll look at it. And it's on your formula sheet. Remember, this was your formula for and. The probability of A and B is the probability that A happens first times the probability that B happens. But when you're doing the probability of B, you're going with the assumption given that A has already occurred. Now, if I want to solve this for this one, then I've got to get rid of this probability of A. Now, how do you undo multiplication? Don't you undo multiplication by division? So I'm going to go over here to both sides. So I'm going to divide this side by the probability of A. And if I do that, then I got to divide that side by the probability of A. So I'm trying to isolate this thing that I've circled. Now, like I showed you here, do you understand that this probability of A and this probability of A are going to divide out on this side? So that's going to leave me what I want isolated. So all I did here was switch sides, just so that it's a little easier to read. If you want to find the probability of B, given that A has already occurred, the formula is that the probability on the top, you have a probability over another probability, kind of like when you were doing odds. You're going to have a fraction over another fraction that you've got to simplify. So you find the probability of A and B, and then you put that over the probability of A. So notice, this denominator is what is on the right side of your bar. All right. So that probability of A, that's why it's A there and not B. It's what you have been guaranteed that's happened. And so that's what it says. The left side is really saying, over here, it's saying what's the probability that B will happen given that A has already happened. So you're guaranteed. Okay. So I'm going to show you two ways to work the problem. Method one is using this formula, and method two is just common sense. Okay. So let's go use the formula on that same problem. So you select one card from the deck. What's the probability that the card is king given that the card is red? Now that bar is red as given that. So what's the probability that you get a king given that, that's the bar, that you're guaranteed the card is red? So do you understand that A is always what's to the right of the bar and B is always what's in front of the bar? So all I did was, this is my formula. I just plugged in my A and my B. So my A is red and my B is king. So the probability of A and B, the probability that they're red and a king, and then it's over the probability of A. And A is what's behind the bar. So that's why it's the probability of red on the bottom. So what I'm really doing is I'm really doing two different probabilities and then putting them together. So like on this bottom, if you were just doing one card, what's the probability that it's red? Remember, what always goes on the bottom is your total. So how many cards are in the deck? What? 52. Of those cards, how many are this thing? Red. 26 of them. So that's why on the bottom down here, I've got 26 over 52. That's what I got when I did the probability of red. Right, like a separate problem, I'm going to do this probability of red and king. Again, what always goes on the bottom of a probability is your total. So 52. Now I'm asking you with and, that means at the same time. So how many cards in the deck are red and king both at the same time? Well, the king of hearts is red and a king. And the king of diamonds is a red and a king. So there are 2 cards that are red and king out of my 52. Okay? Let me erase that. All right. All right. So come back up and draw. Let's see if it'll let me. Well, there we go. Let's try it again. Share the screen. All right. Annotate. All right. So are we clear about why on the bottom it's a 26 out of 52 and why on the top it's a 2 out of 52? So this is the chance that it's just red. That's that bottom, probably that it's red. And this is the chance that it's red and a king both. And like we said, there are only 2 cards in the deck that are red and king simultaneously. The king of diamonds and the king of hearts. Now, like we said before, what happens when those denominators match? Remember, you've got 2 over 52, and you're dividing it by 26 over 52. And most of the time, y'all tend to change it to a multiplication problem. Remember, the first number stays the same. That division turns to multiplication, and then you take the reciprocal of that second number, which means you flip it. So then this 52 is going to divide out with this 52 and leave it 2 over 26. So when those denominators match, they end up going away. So that's why I get 2 out of 26. But that's not simplified, so I put 1 out of 13. So I get 1 out of 13 for the chance, if I know the card is red, what's the chance that it's a king? 1 out of 13. So if you leave me an unreduced fraction, then I'm going to count it wrong. You can either give me approximate decimal or an exact reduced to lowest terms fraction. Now, that's using the formula. That's probably how I'm going to do it. I'm going to use good old-fashioned common sense, okay, because it's quicker. Now, look what I mean by good old-fashioned common sense. Same problem. You select a card. What's the probability that it's a king given that the card is red? So again, I write in my parenthesis what I'm looking for. So if I don't have your event in the parenthesis, you will not get partial credit from me. Okay, so you need to know that. I only get partial credit when I've got something in this parenthesis when you're doing probability. All right, so it says, what's the probability that it's a king given that's the bar, the card is red? Now, do you understand? Are you guaranteed that it's a king or are you guaranteed that it's red? Given that the card is red. So I'm guaranteed the card is red. Now, if I know for sure that the card is red, there are not 52 possibilities anymore. I whittle it down to, if I know the card is red, now there's only 26 possibilities. It's only 26, so the cards are red. Now, if you're going to do it this way, here's the catch. This to the right of the bar becomes your new total. See, new total. So you can't go outside of your total. So when you do these, they have to come out of these. So of these 26 cards, how many are kings? Only 2. And again, if you reduce that, you get 1 out of 13. Because you're guaranteed that the card is red. So there's only 26 cards left now, and only 2 of those red cards would be kings. So I don't care whether you use common sense to work the given that problems or whether you use the formula. That's completely up to you. I need to see your scratch work either way. Okay, so let's go work another one and make sure we're clear about this idea of given that. All right, what if I had this table? Okay. So do we understand? I've got different colors. Some flowers are red, some are white, some are yellow, and I've got different kinds of flowers. I've got roses and tulips. So I want to know, what's the probability if you pick one flower that it's red? Now, what always goes on the bottom is your total. So I've got to add all these numbers up. Okay, so I've got to add 10 to 3 to 4 to 6 to 1 to 8. So you take your calculator and double check and see what you get when you do that. All right, I think we get 31, don't we? Because this is a 10, this is a 10, so that's 20. And 20 plus 11 would indeed get me my 31. So there's 31 flowers up there. Now, of those 31 flowers, how many are red? Now, do you see that all of these are red? Some are roses and some are tulips, but they're all red. So how many red flowers are there? There would be what? 16. So 16 out of 31, I can't reduce that anymore. So that's my probability of getting red. Okay. So we got 16 out of 31. Now, what if I do this instead? And I use common sense. What's the probability that the flower's red given that it's a rose? So are we clear that I'm guaranteed that it's a rose? Now, if I know for sure it's a rose, I can only use these flowers now. So my new total are all the roses. So how many are there in all? Aren't there 17? All right, so of these 17 roses, how many are red? Only how many? 10. So do you see the probability of just red is different than the probability of red given that it's a rose? So what's to the right of the bars is your new total, and these have to come out of these 17 flowers right here. How many are red? Now, what happens when you switch what's on the side of the bars? Well, now the deal is this. All right, so get my eraser. All right, let me erase that. Let me go back up here. Okay. Share the screen again. It keeps wanting to jump. All right. Now, I'm back up here to my table. So remember what we got here on our roses a second ago. All right, we had 17 of them. And then remember above it, we had 10. And remember up here a minute ago, we had a 31. And then we had a 16. Now look right here. This time, I'm not guaranteed that it's a rose. I'm guaranteed that it's red. So now this is my new total. So now I know for sure that I've got 16 flowers. Of those 16 red flowers, how many are roses? 10. So see, none of these are the same answer. So it changes. So you've got to be careful. Whatever's to the right of the bar, that's your new total. And what's in front of the bar comes out of these numbers. Now, why can't I leave it like that? Couldn't I simplify that one? So that one simplify and give me 5 over what? 8. So make sure that you try some of those, given that problem's out of the book. Now let's talk about complements. We've gone over how to get complements, but not when we have compound events. So it'd be a problem sort of like this. What's the probability that if you pick 3 cards from a deck without replacement? So I pick 1 card, 2 cards, 3 cards. Then at least one of your cards is red. Okay. So first of all, do we understand? The first thing I expect you to do is put a P and then put what's in parentheses and what you're looking for. So I need at least 1 red. Now we've talked about this before, but don't just look at the number, look at the modifiers. What does at least 1 literally mean? Doesn't at least 1, at least doesn't mean less than. At least means that's your minimum. So at least means that number or more. So at least 1 would literally mean 1 or 2 or 3. Now, why am I stopping at 3? Because that was my total. I'm only picking 3. So Make sure that you always put what you're looking for, your event, in the parentheses, and then being very explicit. Don't leave it just saying at least one red. What does that literally mean? It means 1 or 2 or 3 red. Now, this problem isn't as straightforward as it looks, because I've got to find all the ways I could get 1 red, or all the ways I could get 2 red, or all the ways I could get 3 red. So what's all the ways that you could get 1 red card if you're picking 3? Well, you could get a red one the first time and a black the second time and a black the third time. That'd be exactly 1 red card. Or you might pick a black first and a red second and a black third. That's a different way of getting exactly 1. Or you might get black the first 2 times and red the third time. That's 3 different ways just to get 1 red card. So I would have to do this probability by doing and, the first one red. So what would that be? I'd have 52 cards, right? How many of those are red? 26. Now remember, I'm not putting it back, so now I've only got 51 cards. Now, how many of those are black? Well, 26 are black, because the one I had was a red card. Now, what about the next one? Well, now I've only got 50 cards. How many of those are black? Well, there were 26 black, but I used one, so now there's 25. So when I multiplied all that, I would have this answer. Well, now I got to go get this answer. I got to start over. What's the chance that they're black? Well, I would get 26 or black out of 52 cards. All right, what's the chance they're red? Well, now I got 51 cards because I've already got a black one over here. So I've still got 26 red ones. Okay, what's the chance the third one's black? Well, now I'm down to 50 cards. I've already got a black one up here, so I've got a black one. I've got 1 black one missing, so now I'm down to 25. So I've got to get this answer and this answer, then I got to get this answer. Now, what do we do with ors? Don't we add them? Then I've got to go get all the ways I could get 2 red cards. Well, I could pick the first 2 red and the last one black, or I might pick the last 2 red and the first one black, or I might get the black one in the middle. So I've got to do this probability and this probability and this probability. Then how can I get 3 red ones? Well, there's only one way. I got to get red all 3 times. So do you understand? I've got to get 1, 2, 3, 4, 5, 6, 7. I got to work 7 problems. And then what do I do with OR probabilities? I add them. I got to add all 7 answers to work this one. Woo! That's just too much trouble for me. Now, can you do it that way? Yes. Will I salute you? Yes, I will. I'm not going to do it that way. That's just too much trouble. So I'm going to show you another way of working it. Now, sometimes there's not another way of working it. Sometimes a problem's just a lot of trouble and you don't have an alternate route. But I've got an alternate route, and here's my alternate route. When I think working a problem and I think, well, that's just too much trouble, then the next thought I want to pop in your head is, could I do 1 minus the probability of the complement? Sometimes I can and sometimes I can't. Okay. So when I'm back over here and I'm thinking, oh my goodness, I could work that, but it's going to take me forever. That's just too much trouble. Then I think, well, could I do 1 minus the probability of the complement? Well, let's see. What's the probability at least 1 is red? Now, what does at least 1 red literally mean? It means 1 or 2 or 3 red. And I think, well, that's just too much trouble. So then I think, well, maybe I could do 1 minus the probability of the complement. So for me to do that, what that means is I've got to be able to find the complement of this. Now remember what complement means. Complement's everything in your sample space with this deleted. So I'm going to go over to the side and write down my sample space. If you draw 1 card, if you pick 3 cards, what are all the number of red ones you might get? Well, you might not get any red ones. You might get 0 red ones. Or you might get what? 1 red one or 2 red ones or what? All 3 could be red. If you pick 3 cards, that's all the possible number of red cards. So if I delete this, the 1, the 2, and the 3, what's the only thing left? What's left is the complement. That would be 0 with that same word, red. So if you don't pick 1 or 2 or 3 red ones, you must have picked 0 red ones. So what I could do is I could do this problem and subtract from 1 if it's faster. Well, now think about it. What if I've got cards, they only come in 2 colors, red and what? Black. So what's the same thing as getting no red ones? Getting all what? Black. And the reason that I like this one better, there's only one way for all of them to be black. The first one's black and the second one's black, what? And the third one's black. So I've only got to work this one problem. So I'm doing the probability of black. Now, what do you do with and? Don't you multiply? And the probability that the second one's black and the probability that the third one's black. Now, remember, it says without replacement. So I've got to remember I'm not putting them back. So when I go in the first time, what's my chance of getting a black card? Well, there are 22 cards and 26 of them are black. So in my hand is 1 black card. It's over here. So when I go back in to pick my second card, what's my total now? It's not 52, it's only what? 51. And how many black cards are there? Well, now there's only 25 black cards left because remember, one of them's over there. Then when I go back for my third pick, what's the chance that one's black? Now again, I picked 2 cards, so now I'm down to 50 cards. Remember, I'm assuming these 2 things have already happened, so they're both black. So now I've only got 24 left. So when you multiply straight across the top, you get the 15,600. When you multiply straight across the bottom, you get this number. When I divide and round, I get about this number. So this one is the answer to this. Now here's what I get a lot of times. Somebody will box this answer right here, like I've got. Now, do you see why that's not right? This is the answer to that. I've still got to take that number, that 0.1176, and I've got to subtract it from 1. So my final answer is 0.9924. Woo, that's a big probability that I'm going to get at least 1 red card if I pick 3. So if you're going to do 1 minus the complement, you've got to figure out exactly what the complement is. And then when you calculate that probability, you've got to subtract from 1. But now here's the lovely part. If it's at least 1, the complement's always going to be 0, because if you have at least 1 out of 10, that would be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. So the only thing missing would be 0. But now later, we're going to say things like, what's the probability that you get at least maybe 2, if I could spell, at least 2 are red. Well, if I wanted the probability that at least 2 are red, now what would that literally mean? That would mean 2 or what? 3 are red. Now, we're going to do this kind later. This in homework, I think all of your homework is just at least 1. But later when we get to this, I would do the same thing. I'd go to the side and go, okay, how many red cards might I get? This. So if I delete the 2 and the 3, 1 minus my complement would be 0 or 1 red. So let's make sure that we're clear. To get complement, you write down all the possibilities and you cross these out, and what's left is your complement. Okay? So hopefully you can kind of work on that homework and let me know if you're having any issues with it. Okay? So if you're having any issues with conditional probability, like at least 1, and you're confused about how to do 1 minus the complement, let me know. Or if you're confused about given that, let me know. Okay.